Okay, so in this lecture video, we will solve the sample problems under the study guide for module number 2, and it's under the topic planning and scheduling, or the PERT CPM. Okay, so this is already discussed, so we will just remember the formulas again for expected time. We have here the expected time T is equal to T sub O plus 4T sub M plus T sub B all over 6. Now, we have here the T sub O as the optimistic time estimate, the T sub M as the most likely time estimate, and the T sub P as the pessimistic time estimate. So, using this formula, we will solve the sample problem number 1. So here we have here we have the duration of each activity. So this is the activities A to H, and we have here the T sub O as the optimistic time estimate, the most likely time estimate, and the pessimistic time estimate. So all we need to do is to solve them using the formula time. So it's asking for the duration or the time T. So for the duration of that activity, for example, activity A, so we have their formula time T is equal to T sub O plus 4 T sub M plus T sub P all over 6. So all we need to do is input the values for T sub O plus 4 times T sub M plus T sub P all over 6. So that is equal to that's 10 plus 4 times 8 plus 16 divided by 6. That is equal to 9.67, or that is 10 days. So we will put here 10 days. Next, for time of B, so we have there 12 plus 4 times 10 plus 18 divided by 6, and that is equal to, so there's 12, 4 times 10, and then 18 divided by 6, so that is 11.67, that is 12 days. So there's no such thing as 11.67 days, so we round it up to 12 days. Next, we have the time for C. We have there 11 plus 4 times 9 plus 15 divided by 6, and that is equal to, so 11, 4 times 9 plus 15 divided by 6, that is 10.33. So how many days is 10.33? We will put here 11 days. Okay, so we have a surplus of 0.33 days, and we will consider that as an extra day or another day. Therefore, instead of putting here 10 days, we will put here 11 days. Okay, so we have time D. So at time D, we have there 16 plus 14 times 4. Okay, so 4 times 14 plus 21, and that is over 6. So 15 point. So that is 15.5. That is 16 days. Time E. So time E now is 14, 12, and then 19. 13.5. 13.5, and that is 14 days. Time F, that is 21 20, and then 26. It's 21.16 or 17, or that is 22 days. Time G. So time G, we have there 18, 15, oops, and then 20. 16.33, or that is 17 days. And then finally, we have time H. For time H, we have 15, 12, and then 24. So 14.5, or that is 15 days. Okay, so we'll put here 11, 16, 14, 22, 17, and then 15 days. So this is the duration per activity. Okay, that's for example number 1. Okay, next we will proceed to the next example. So before that, we will need to review again the terminologies used in CPM. So again, the activity carries the arrow symbol. So this is the activity. So if the activity is in letters, so we can use it in letters, or if it is in numbers, we can use it by number representation, or maybe whatever symbol that activity is. Next, event is a node denoted by a circle and marks the start and completion of an activity. So this is your activity, and the node or the event is found here and here, okay, at the tail and the head of the arrow, which signifies the start and completion of a single activity. Next, we have here the dummy activity. So what we need to remember here, a dummy activity is represented by a dotted arrow and does not consume any time and resource. So this is the symbol of the dummy activity. Next, we need to remember what path is. So a path is a series of adjacent activities leading from one event to another. Okay. And then what we need to remember when it comes to the arrows, here this signifies the activity A, activity B, and then activity C. If this is the orientation of our network, it only means that A must finish first before either B and C can start. Okay, and this pattern here signifies that both A and B should finish first before event or activity C can start. Then we need to remember this part also. This orientation or this pattern here means that A must finish first before B can start, and both A and C must finish first before activity D can start. Now you can see here a broken arrow here. That is your dummy activity. Okay, so what we need also to remember in our discussion is that the earliest time here, the ES, is the earliest time an activity can begin without violation of immediate predecessor requirements. So it's the earliest time an activity can begin. Okay? without affecting the duration of the entire project. So you must remember that. So this time here, the earliest time, the earliest start time, the earliest finish time, the latest start time, and the latest finish time, they should not affect the they should not adversely affect the duration of the entire project. Okay, now let's go to the earliest finish time. So earliest finish time, or the EF, this represents the earliest time at which an activity can end. And then we have here the latest start time, or the LS. This is the latest an activity can begin without delaying the entire project. And the latest finish time is the latest time an activity can end without delaying the entire project. Okay? And as for the float, we have two formulas for the float. You could either subtract the earliest start from the latest start, or you can subtract earliest finish from the latest finish. Whichever of these two formulas you are to use, they will have the same outcome. Okay, and that outcome is the float. Okay, let's solve the example number 2. So here in example number 2, fill in the table, find the critical path and the duration of the project. So the rule of thumb here is that we need to draw the network first, the network diagram first. Okay, so we have here the arrow diagram and the precedence diagram. So this signifies the activity, and then this signifies the event, or the node. Okay, and this is the duration of each activity, and then we will fill up this fill in this table here. Okay, so first, the network diagram. So we have here the activity number 1. So for the activity so we have here the event 1, and then this is the activity here. Okay, let's see if let's just put it here. So this is 1, and then this is the end of the arrow. So this signifies our activity. Then we have here, I prefer that the activity should have a letter on it rather than the number. And then we have here 1, 2, 3. So we have here the arrow 1, 2 to 3 here. So let's name this as activity 1. And then we have here activity 2. And then we have here, you see here, we have 3 nodes here. Okay, number 3 nodes. That means we are going to see 2 arrows from activity from the node 3. So I will put here the other one, and then this one is the other arrow. It means that the activity here, let's name this as 3, and then this is activity 4. This means that activity 3 and 4 cannot start without number 2 activity finishing first. Okay, So let's name this as node 4, and this is your node 5. And then there is no activity for 4 to 5. That means we have here a dummy activity for node 5, node 4 to 5. Then we have here 5 to 6. So this is our last activity. So activity 5. Then we will put here the duration just below it. So let's use a blue color for so here we have duration 2, 1, and then 3 to 4 we have here 1 day duration, and then 3 to 5 it has 2 days duration, and then 5 to 6 has 5 days 1 day duration. Okay, so as for the dummy activity, there is no duration for this. What does it mean? Okay, it means that since this activity 3 from event 3 to 5, it is parallel with the event here node 3 to 5. So it's this one here is parallel with this one. So since it is 2 days, you can move this activity number 3, you can move that into here. So if ever there is an event at the site, you can move activity 3 on this dummy activity here, and it will not affect the total duration of the project. Okay, so what is the question here? Find the critical path. So here in this pattern, we have here how many paths. So let's write here. So we have first path here is 1, 2, 3, 5. Okay, so the first path here is 1, 2, 3, and 5. And then the second path here, we have here 1, 2, 4, and 5. So we have 1, 2, 4, and 5. So which of these two paths have the highest duration, so greater duration? So it means duration is not simply adding this in the table. You must first determine the paths, and from each path you need to solve for the duration. So for 1, 2, 3, 5, we have here 2 days plus 1 day plus 1 day plus 1. So that is equal to 5 days. And then for path 1, 2, 4, 5, we have there 2 plus 1 plus 2 plus 1, and that is 6 days. Therefore, the critical path is this. So this is your critical path. So 1, 2, 3, and 5, and 6 days here is your duration. So that's the duration of the entire project. Okay, and take note when you're looking for a float, so you need to focus on whether the parallel activity here is along the critical path. So you see here that we found out that this activity here is parallel with this activity, and since this is your critical path, along the critical path, you're able to see that this is your float. Okay, so that is the float. Okay, so we were able to find the critical path and the duration of the project. Now we need to fill in this. So fill in the table. So how do we fill in the table? Alright, So I need to memorize this orientation. I will be using this table here. So get used to this orientation here, which I will be using in this example. So here we have the activity, and then we have here the duration, and then we will put the earliest time here, and then we will put the early finish here. This is your latest start, and then latest finish. Okay, so this is our orientation. Now I will put here table. Okay, for activity number 1, okay, here. Okay, so how are we going to put it here now? So this is our activity number 1 here. Okay, I will arrange this first for us to get this properly. I should have made it bigger. Okay, so I will put here our table. So remember that in here, activity number 1, we have 2 duration. And then in activity 2, we have 1 day duration. For activity 3, we have 1 day duration. For activity 4, we have 2 days duration. Activity 5, we have 1 day duration. Okay? And then as for the earliest start, so let's use another color. For earliest start here, that will be 0 because there's no activity prior to the start of the activity. So what is 0 plus the duration here? 2. So the early finish here is 2. So 0 plus 2 equals 2. Next, we have here the early finish. So early finish is at the lower left. So early finish now here is again 0. And then 0 plus 2, that will be 2 for the latest finish. Now here in activity number 2, we have the earliest start. So for our early start, we see here that activity 1 should finish 2 days first. So we will put here 2 days. Okay? And then 2 days plus the duration of the project, which is 1. And that is equal to the early finish. So that is 2 plus 1 equals 3. And then for the late start, so what will be the latest start for this activity 2 to begin? So that is 2 days. So 2 plus 1, and that is 3 days. Next, we will go to activity number 4. Okay, let's go to activity number 4. We have here the earliest start. The earliest start for activity number 4 is that the activity 1 and 2 should finish first. So that means that will be 2 plus 1, and that is the early start for activity 4, 3. And then we have here duration of activity 4 is 2 days. So 3 plus 2 equals 5 days for the early finish. And for the late start, you can notice that for the late start, it is similar with the early start because you need to finish 1 and 2 first, right? So 3 plus 2, that would be 5. And how about here in activity 3? Okay, for activity 3, you have here your earliest start. So for activity 3, your earliest start means the earliest time the activity can begin. So if activity 1 and 2 finish on time, that will be 3 days, right? So 3 plus 1, that will be 4. Now, how about the late start? Okay, where can you put the activity 3 if it is to start late? Remember, it is parallel with activity here, activity 4. And you can move activity 3 in this part here, in the dummy activity, because activity 4 has 2 days and activity 3 has 1 day. So, if activity 3 is moved here, the late start then becomes what? So, how do you now determine the late start? So, determining late start means that is 2 duration for activity 1 plus 1 duration for activity 2 up until here, up until node 5. So 2 plus 1 plus 2 for activity 4. And then minus the duration of the activity 3. So as you can see here, I did the backward. So 1, 2, and then going to node 4. So the computation for the late start for number 3, activity 3, is equal to 2 plus 1 plus 2 and then minus 1 of the activity for activity 3. So that is equal to 4 days. Okay, so 4 days, and then you can get now the late start as 5 days. Okay, next and last, we have here the activity number 5. So for activity number 5, since this is here after activity 4, so we need to finish first activity 1, 2, and 4 before we proceed to number 5. So we have here 2 plus 1 plus 2, and that is equal to 5 days. So 5 days before activity 5 can start, and then 5 plus 1, that is equal to 6 days. And then notice that for the late start of activity 5, so you cannot move this anywhere anymore, right? You cannot move this activity 5 anywhere. Therefore, it's the same. Late start is the same with the early start, and the late finish is the same as the early finish. So we were able to complete our requirement now. And what I want you to notice is that whenever an activity is along the critical path, so this is your critical path, right? So along the critical path, an activity will always have the same early start and the same early start and late start, and the same early finish and late finish. Also, I want you to notice that your part here is the same as this one here, and then your last part here is the same as this part here. So it will be easier to transfer here from one diagram to another. Okay, and if for you to find out if what you did is correct, take note that the duration is 6 days and the last part here should be 6 days. Okay, now we can fill in the table. Early start for activity 1 is 0, and then the late finish is 2, late start, late finish. Next, for activity 2, we have here early start 2, early finish as 3, late start 2, and then early finish 3. Then we have activity 3. For activity 3, we have early start as 3, early finish as 4, late start as 4, and then late finish 5. For activity number 4, we have here early start 3, early finish 5, late start 3, late finish 5. For activity 5, we have here early start, early finish, late start, and then late finish. Now, looking for the float, the formula again for float is, so total float is either we have here ES, or should I say, okay, so LS minus ES, or that is late finish minus early finish. So whichever you use, okay, this should be the same. So the total float for activity 1 is 0 minus 0, that is 2 minus 2, and that is 0. 0 here. So for activity 2, we have here 2 minus 2 and 3 minus 3. For activity 3, we have 4 minus 3 and 5 minus 3, 1. We have for activity 4, 3 minus 3, 5 minus 5. Activity 5, we have 6 minus 6 and 5 minus 5, 0. Therefore, total float now, so our total float is 1. Okay, so total float is 1. If it is asking for the total float. Okay, so that's example number 2. Let's try to solve for example number 3. Fill in the table, find the critical path and the duration of the project. So we have here the activity represented by letters, and the predecessor or the activity prior to it is in the table. We have also here the duration per activity in the number of days, and fill in the early start, early finish, late start, and late finish. So first we need to draw the network diagram for this. So drawing network diagram, there is no node. I will just put here node. Say this is our activity number, letter A, so put here 0, 0, and then 2. Okay, no, 1, should be 1. So this is our activity A, and we will be using again our table. Duration for activity A is 3 days. So we have here 3 days. Next, we have activity B. The predecessor is activity A. And you can see here that both B and C will start after activity A. So that means there will be a branching out here. Will branch out here. It will burst. So this is now our node 2. I'll put here node 2. I will put here node 3. And this is our activity B. And this is our activity C. And then we have activity D. So activity D will start after activity B. So our activity D is located somewhere here. So we'll put it here. It's too big. So not necessarily that your network diagram should look perfect. It should, in a way, look nicely, or in a way you can understand your solution. Okay? So this is for activity D. Oops. Next, we have activity E. It will start after finishing activity C. And notice that both E and F will start when activity C is finished. So activity C will branch out. Okay, so it will branch out. So something like this. So this is now our node 5, node 6. So this is C, so this is E, and then this is F. Next, let's go to activity G. It says there, for activity G, it will start when D and E is finished. So where is D and E? So D and E. When they are finished, activity G will commence. Therefore, I will need to adjust my drawing. So it does not look like that. It will look like this. Because they will merge, right? They will need to merge. Why? It's because activity E and D, so E and D should finish so that activity G can start. So this is your activity G. So since we remove node 5, we'll put node 5 here, and then we will use node 6 here. So this is activity G. Next and last but not the least, we have H. So activity H will start after activity F and G. So where is F and G? So F and G should finish first before we can start with H. So what does it mean? That means G and F will merge. So our drawing needs adjustment again. Okay? So we will need to adjust this because they will meet. Okay? So they will meet. So let's do some arrows like this. So this is now our node 5. So this is G, and then this is F. So that activity H will start. Node 6. Okay, so this is our activity H. Okay, so we were able to draw our network diagram now. So we will determine the critical path. But before that, let's put here the table, small table. Again, for our orientation, we have here the activity. This is our duration. Then we will put here the early start. This is the color that we will use. So we'll put here the early start, the early finish, the late start, and the late finish. Okay? So for activity let's put the duration first. For B, the duration here is 4 days. For C, the duration is 2 days. For D, the duration is 5 days. For E, the duration is 1 day. The F has 2 days duration. G, 4 days. H is 3 days. Now let's go to the early start. For the early start for activity A, of course, that is 0. We will have the critical path first. So we will find the critical path first. So let's list down the paths. So we have here path A, B, D, G, H. So I will put here A, B, D, G, H. Then we will have another path here, A, C, E, G, H. So that is our second path. So A, C, E, G, H. A, C, E, G, H. Next path here will be A, C, F, H. So A, C, F, H. So for the duration of A, we have 3, 3, 3. Plus B, 4, D, 5, G, 4, H. We have A, C, E, F, A, C, E, F, H. We have A, C, F, H. That is A, C, F, H. Okay, and then we will now compute for the duration. So 3 plus 4 plus 5 plus 4 plus 3. So this is 19 days. So 3 plus 2 plus 1 plus 2 plus 3. So we have here 11 days. And then we have here 3 plus 2. Okay, this is 10 days. Therefore, the duration of the project is 19 days. So this is the duration of the project, and the critical path is A, B, D, G, H. So we will now have the path of A, B, D, G, H. So here, so that is the critical path, right? So now we were able to determine the critical path and the duration. We will now fill in the table with the early start, early finish, late start, and late finish. So for activity A, we have here early start as 0, and then 0 plus 3, so that is equal to 3 as the early finish. And since it is along the critical path, you can have here same early start, same late start, and late finish. Next, for B, B will start after A is finished, so that is 3 days. 3 plus 4, we have here 7 for the early finish. And then since it's along the critical path, this is also 3 and 7. For activity D, we will put here, so how many days before A, how many days before D can start? So A and B should be finished. So that is 3 plus 4 equals 7. And take note, it's the same as this one here. So 7 plus 5, that is 12. And it is along the critical path, so this is the same. For G, copy this one here. So this is now the shortcut. 12 plus 4, this is now 16, 16. For activity H, along the critical path, copy this one here. So 16, 16, 16 plus 3, and this is 19, 19. So we're done along the critical path. So it is very easy when you're doing this along the critical path. And it is correct because look at this. It's the same as the duration of the project. Okay, so now let's go to activity C. Okay, for activity C, you can see here that activity C and E, so they are parallel to this one here. Activity C and E has start node 1 and end node 4. Okay, So start node 1 and end node 4 is also the same for B and D, which is along the critical path. Look at this. B and D has 4 plus 5 days, so that is 9. While activity C and E has 2 and 1, so that is 3 days. Meaning to say that along this activity, C and E, along this, we will be able to find a dummy activity. Okay? Which means that you can move this activity E and activity C farthest. Okay? So you can move it here at the 9th day. Okay? 9th day. So how do we now compute for the early start for activity C? So for activity C, the early start here is that it needs to have activity A finish first. So that will be in 3 days. 3 plus 2, that will be 5 days. Now how about the late start? The late start, you will be able to find it by doing this method. For late start of C, let's put it here. For the late start of C, activity C, notice this. We will do this method. We will have here activity A plus B plus D. And then, so we will have here, so activity A plus B plus D minus E and C. Okay? So we will determine now the late start. Okay, again, may I repeat? It will be activity A, duration of A, duration of B, duration of D, plus A plus B plus D. And then, minus activity E and C. So, we'll put here, duration of A is 3, plus duration of B is 4, plus duration of D is 5, minus, so we're going to do backwards, minus the duration of E, minus the duration of C, which is 2. And that is equal to, so calculator here, so 3 plus 4 plus 5 minus 2 minus 1, sorry, minus 1 minus 2. So that would be, 3 plus 4 plus 5 minus 1 minus 2. So that is 9 days. So that is 9. So we will put here now 9 as the late start. And then late start plus the duration 2. So that will be 11. So look at this. We were able to complete now for activity C. Now how about for the late start of activity E? So again, we will solve first what is the early start. Okay, early start here. The earliest time that activity E can start. So activity E can start when C is finished. And you can get it by here. Okay, so that will be activity A, 3 plus 2, 5. So we have here 5 days for the early start of activity A, similar with the late start of C. And then 5 plus 1, that will be 6. Next, the challenge here is the late start. Late start of E. So let's see. This is late start C. Late start E. So late start E is equal to, what will we do? Again, that will be activity A, B plus D duration. And then minus the duration of E. So that will be 3 plus 4 plus 5 minus 1. And that is equal to, so 7 plus 5 minus 1. That will equal to 11 days. So we will put now here for activity E, 11 days for the late start, then 11 plus 1, that will be 12. Okay, we're done with activity E. Let's go for activity F. Now for activity F to start, sorry, A and C must finish. So for F, we will copy D, late finish for C, so that is 5. So 5 plus 2, that is 7. Now how about the late start? So you see here for activity F, and looking at the critical path, we have a parallel activity here. So the end part here is number 5, event 5, and then its parallel here will be event 1 or node 1 to 5. So it's parallel for this portion here of the critical path. Okay? So what will we do here is for the late start for activity F, we need to add. So we need to add here activity A, B, D, G. So G. So it ends with the node 5, and then we will minus the duration of F. So that becomes your late start. So that will be 3 plus 4 plus 5 plus 4, and then minus 2. So that is the late start for activity F. 3 plus 4 plus 5 plus 4 minus 2, and that is equal to 14. So 14 days. So we'll put here 14. 14 plus 2, and that will be 16. So we're able to finish now the computation here. We will now fill in the table. So we will fill in the table. Activity A is now early start. Oops. Should be blue. Early start 0, early finish 3, early start 0, early finish 3. For activity B, that will be 3, 7, 3, 7. For activity D, we have 7, 12, 7, 12. G, 12, 16, 12, 16. And then H, we have 16, 19, 16, and then 19. As for the float, so it's not stated here, but I will write it now. For the total float, the float is 0, 0, 0, 0, 0, 10. That's their floats. Now, as for the activity C, for activity C, we have here 3, 5, 9, and 11. For the float here, we have 9 minus 3, 6. Or we have 11 minus 5, 6. Therefore, the float here is 6. Next, for activity E. For activity E, we have 5, 6, 11, and then 12. And then for the float, we have 11 minus 5, and that is 6. 12 minus 6, and that is again 6. So total float there is 6. For activity F, we have 5, 7, 14, and 16. So that is 14 minus 5, and that is 9. So we have here 16 minus 7, that is 9. So total float here is 9. Okay, so the table is now complete. So that is example number 3. Let's go to the example number 4. Now for example number 4, given the following data for a building to be constructed. So we have here the activity, and then here is the letters representing the activity and the nodes. Then we have the duration in weeks, It's looking for the critical path of the project, duration of the project in weeks, and it's looking for the earliest activity for earliest start of activity M in weeks. Again, let's do the critical the network diagram, CPM. Okay, so we have here for activity 1, we have node 1 to 2. So node 1 to 2 for activity A. And then for activity B, this is their node 2 and 3. So, and take note, it says here, same nodes for C. Activity B is node 2 to 3 and activity C is node 2 to 5. Meaning, they have the same starting nodes. So, it will branch out, right? So, it will branch out. Say this one here and this one for, so let's do a draft first. So this is activity 2 and 3, 2 and 5, so we'll put here 5. So this is B and C. Next for D, we have 3 to 4, so this is D. And then for activity E and F, we have E, F, G. They have the same nodes. So here 4, 1, 2, 3. So that's weird. So we have here 5. No. Okay. So we have node 5 here already. So 5. Therefore, one of them will proceed here. So we will extend activity C. And here we have a dummy activity 4 and 5. And then we have another 3 branching out here, that is 6, then 7, and that is F and G. Then 5 to 7, so here it is 5 to 7, so that is H. 5 to 8, and that is I. 6 to 7 here is J. 7 to 8, so 7 to 8, that is K, that is dummy activity. Okay, 7 to 9, so we have here 7 to 9 as L, and then 8 to 9 or M, and then 9 to 10 here. So it does not necessarily mean that you have a perfect and beautiful diagram. All you need to do is something that is readable enough. Okay, let's put this in a proper drawing. Okay, let's arrange this one in a proper way. So this is for activity A. Then activity B branches out here. Then activity D. Then this is activity C. We'll just put it right here. And then this is now the dummy activity E. And then for for F, we will have here, let's just put it here. This is F, and then we have here G. So let's put here 7. And then 5 to 7 for H. And then 6 to 7 for J. Seven to 9 for L. And then 5 to 8. So let's put here 8. Since this is now our 8, let's put here 5 to 8. 5 to 8 for I. Okay, and then we have 7 to 8, the dummy activity. Okay. Then we have 8 to 9 for M. And then finally, we have N. Okay, so it's now complete. Let's delete this, erase this one here. This is now our, I cannot say this is much better. Okay, but well, maybe a little bit presentable than the previous. Okay, and then let's put the duration. So it's in weeks. For A, we have 8 weeks duration. For B, we have 14. D, we have 5 days duration. For E, no, there's none. F, or where is the C? So this is C. 2 to 5 is the C, that is 6. For the F, we have there 6 as well. For G, we have 6. For H, we have 4. I, we have 12. J, 12. So this is J. And the duration is 12. The L here is 10. And then we have M, 12. N is 8. Okay, so we now have the duration. Now for the paths, we have plenty. So first one here is A, B, D, F, J, L. So A, B, D, F, J, L, M, N. So, no, that's not correct one. Do we have a 9 to 10? Ah, yes, we have 9 to 10. So 9 to 10 here. It should be here. It's not 8 to 10, it's 9 to 10. So this is N. 9 to 10 N. And that is 8. Okay. So again, we have A, B, D, F, J, L, N. So that's the first path. So we'll put it here. So we have A, B, D, F, J, L, N. Then we will count how many duration we have here. We have 8 plus 14 plus 5 plus 6 plus 12 plus 10 plus 8. So 8 plus 14 plus 5 plus 6 plus 12 plus 10 plus 8. We have here 63. Yes, we need to move here. 53 weeks. Next path, A, B, D, F, no. So, same. A, B, D, G, L, N. Oops. So, A, B, D, G, L, N. Okay. So, that's the second path. So, A, B, D, G, L, N. That is 8 plus 14 plus 5 plus 6 plus 10 plus 8, and that is equal to 51 weeks. Next path, we have A, B, next D, which one? G. We have here K. We'll be using the dummy K, then M, and then N. So that's the third path. Okay, so that's our third path there. A, B, D, G, K, M, N. So that is equal to 8 plus 14 plus 5 plus 6 plus 0 plus 12 plus 8, and that is equal to 53 weeks. Next path, we have there A, B, D, A, B, D, we can use again this one, F, J, K, M, N. So that's our fourth path. Okay. So we'll write that down. A, B, F, J, K, M, N. That is equal to 8 plus 14 plus 5 plus 6 plus 12 plus 0 plus 12 plus 8. That is equal to 65 weeks. Next, we have another path. A, B, D, dummy E, H, L, N. So that's the fifth path. So A, B, D, E, H, L, N. 8 plus 14 plus 5 plus 0 plus 4 plus 10 plus 8, and that is 49 weeks. Next path, we have A, B, D, E, H, K, M, N. Okay, so that's another path. So we have here A, B, D, E, H, K, M, N. That is equal to 8 plus 14 plus 5 plus 0 plus 4 plus 0 plus 12 plus 8, and that is 51 weeks. Okay, so we already have 6 paths. 1, 2, 3, 4, 5, 6. So 6. How about the 7th? I can still see more. So A, B, D, E, I, M, N. Okay, so that's another path. So A, B, D, E, I, M, N. So that is 8 plus 14 plus 5 plus 0 plus 12 plus 12 plus 8, and that is 59 weeks. So still there's more path here. So A, C, H, L, N. So AC, H, L, N. So 8 plus 6 plus 4 plus 10 plus 8. And that is 36 weeks. And I think this is the last path. A, C, A, C, I, M, N. No, it's not. So I think we are able to determine now what is the critical path here. So this A, C, H, K, M, N. And then if we add with this one here, so our critical path now is the 65 weeks. So this is our critical path. And this 65 weeks is the duration of the project. Okay. So critical path is located in A, B, F, J, K, M, N path, and that is 65 weeks duration. Okay. So we now have here let's highlight the path A, B, F, J. No. Oh, I did not ABD. It should be ABD. Sorry. ABD. So the critical path should be ABD. FJ. Okay. So ABD, FJ, K, M, N. So that is our critical path. Next, so we're able to answer here A and B. Now C, for letter C, give the earliest start of activity M in weeks. So where is activity M? So our activity M is here. Okay, so how it is along the critical path, right? So it is along the critical path. How do we determine now the earliest for letter C? Earliest what's that? Earliest start. So ESM. For ESM, we have here activity it should be along the critical path. So AB, so A, B, D, F, J, K. So that will equal to 8 plus 14 plus 5 plus 6 plus 12 plus 0, and that is 45 weeks. So that is 45 weeks for early start of activity M. Alright? So what if the question here is, so side question. So side question if what is the early start of say activity I. So where is activity I? So here is the activity I. So how do you determine the early start of activity I? So again, you need to focus on the critical path. So where does activity I end with respect to the critical path? So this is the critical path. So activity I has same node with the critical activity here at node 8. So what will we do here is you add A plus B plus D plus F plus J plus K and then minus 12. That is your early start for I. So let's do that. So for early start of I, we have there the duration A. So A plus B plus D plus F plus J plus K minus I. So we have here 8 plus 14 plus 5 plus 6 plus 12 plus 0 minus 12. And that is equal to, so 8 plus 14 plus 5 plus 6 plus 12. This is a side question, okay? So 45 minus 12, so 33. So 33 weeks as the early start for activity I. Okay? So that is for example number 4. Alright, so let's go to example number 5. So the activities, duration, and cost under normal and accelerated conditions for a network diagram are shown in the accompanying table. So we have here the table. So we have here the normal cost and the accelerated cost. What do you mean by the normal cost and accelerated cost? For normal cost, it is the based on the normal activity and normal budget of the project. Whereas the accelerated cost is wherein you impart an additional technology or something special in order to accelerate the project. For example, normally you just hire laborers to dig using a shovel, whereas the accelerated cost, you use tools or you use machines to dig for the project. So it will accelerate the project, but take note, the cost will rise or there will be increase in cost. Now, what is the question for example number 5? Give the critical path of the network. Letter B, which activity is most cost efficient in converting to the accelerated program? Letter C, if the maximum budget is 22,600 pesos, determine the reduction in the number of days to complete the project. Okay, so let's solve this one. First and foremost, we need to draw the network diagram. So it says here, the node 0 to 1 and node 0 to 2, they have the same node. 0. Oh, no, 3. There's 3 activities with the same start. So we will just put here 0 and then it will branch out into 3 activities. So, okay. You can use this type here. So 0 to 1, 0 to 2, 0 to 3. Next, no. Let's put it here. So we have here 1, 2, 3. Let's just try. And then says here activity C will have the node 1 to 2. So 1 to 2. So this is activity A, B, and D. Activity C. And then we have here, for activity E, we have 2 to 3. And then 3 to 4 for F. Okay, that's quite not cute. Okay, let's see. Since this is a shorter project, so let's put here the normal days. The normal days here. The duration for A is 3, B is 4, and then C is 5, D is 3. No. C7. Sorry. It should be C7. C is 7. D is 3. E is 4. And then we have F5. F and then 5. So which path will take it longer before reaching F or after F? So we have here 3, 7, 4, 5. That would be 10, 19. 10, 19. We have here 4, 4, 5. Okay, so this one here is longer, right? So 0, 1, 2, 3, 4. So 0, 1, 2, 3, 4. So I will do that. I will just arrange our diagram. 0, 1, 2, 3, and then 4. So 0, 1, 2, 3, 4. So this is longer. And then we have 0 to 2 for B. So 0 to 2 for B, because we have A for 0 to 1, 1 to 2 for C, 2 to 3 for E, and then this is F. How about D? Where is D? 0 to 3. Okay, now this looks more presentable. There we go. Then for the duration, we have there A 5, B is 5, C 7, D 3, E is 4, and then F is 5 days. Okay. Now for the paths, so we have here a B E F path B E F. Then we have here path A C E F. A C E F. Then path D F. So D F is just simply 3 plus 5 equals 8. A C A F is 5 plus 7 plus 4 plus 5. And that is 21 days. So this is the duration of the project, because in BEF this is just simply 5 plus 4 plus 5, so that is 14. So the critical path here is ACAF, so CP, and then the duration here is 21 days. And question B, which activity is most cost efficient to converting in the accelerated program? So this is for A. Now B. So our maximum budget, so given our max budget here is what's the normal cost, total normal cost? So 1,000 plus 3,000 plus 2,000, 12,000, 1,000, 2,000. So that is 21,000 pesos. So we have here the maximum budget given is 22,600, and the normal budget is 21,000 pesos. So we have 1,600 cost to accelerate some activities. Okay, so that is the cost to accelerate some activities. Now you have to note here, accelerate items or activities along the critical path. So this is something to remember, okay? So accelerate items along the critical path. Okay, also we need to consider this formula, cost of crashing is equal to the crash cost minus the normal cost divided by the normal duration minus the accelerated duration. So again, this is something to remember, this is our formula. Okay, so we have critical path A, C, E, F, right? We will have here activity A. So our maximum crash time. What is our maximum crash time? Consider this. Maximum crash time for activity A is 5, the normal, minus the 3 days accelerated. So maximum time is 2 days. Okay. AC, okay, this one here, 7 minus 5, 2 days. E, 4 minus 3, 1 day. And F, 5 minus 3 is 2 days. So we will put here maximum crash time for A is 5 minus 3, 2 days. Now cost for crashing. Cost of crashing. So how much? It says there the formula is crash cost minus normal cost. So it is crash cost minus the normal cost and then the maximum crash time. So that is the 5 minus 3. So that is 1,600 minus 1,000 divided by 5 minus 3. So that is equal to 300 pesos per day. Now for activity A. Activity C, the maximum crash time, as we have seen in the table, that is 7 minus 5, that is 2 days. Then cost of crashing, that is equal to 2,500 divided by minus 2,000 divided by 7 minus 5, and that is equal to 250 per day. Now for activity D, okay, so I think we need to add an extra page on this one. There we go. For activity E, so max crash time is 4 minus 3, that is 1 day. Cost of crashing, COC, so cost of crashing is 1,500 minus 1,000, that is 4 minus 3, and that is equal to 500 per day. Then for activity F, so maximum crash time, and and that is equal to 5 minus 3, and that is 2 days. And then cost of crushing is equal to 2,800 minus 2,000 all over 5 minus 3. It is equal to 400 per day. Okay, so from this, which is the most cost-efficient or cost-effective activity to crush first? So, note, okay, I will put here the most cost-efficient or the most cost-effective activities or activity, the activity to crush first, or activities, yeah, maybe you can use maybe there are plenty of them. So the most cost-effective activities to crush first are those that have least cost of crushing. Okay, so again, you have to take note of that. So among these activities, which has the least cost of crushing? So least cost of crushing is 250 days. Therefore, activity C is most cost efficient. Okay, activity C, efficient to crush. So answer here is activity C. Okay, so that's for letter B. We still have to answer letter C. So we answered A and B already. How about C? So given the maximum budget 22,600, determine the reduction in the number of days to complete the project. So it requires us to use the maximum budget. So since using the maximum budget 22,000 leaves us with 1,600 pesos as cost to accelerate some activities. So we will have here letter C. So cost to accelerate duration. Okay, so activity C is to be crushed first. So that is 250 pesos per day. We have there 2 days. So that means so we have here cost to crush. Our cost to crush here is 1,600 minus 250 times 2, 500. So we still have 1,100 pesos to use to crush other activities. So we have there activity, which one among this? Activity A, E, F. I will choose the least cost of crushing, this one here, activity A, and crush time is 2 days. So we have here activity A. So that is 300 pesos times 2 days. So that is minus 600. So we have here 500 pesos. So we still have 500 pesos here to crush activities. So which between activity E and F will we crush? So the cheaper one here will be activity F. So it says there 400 pesos per day. And then here activity E, for 1 day, you will pay 500 pesos. Whereas maximum crush time for activity F is 2 days. So as for me, I will choose here activity F because I can accelerate the program by 1 day. So instead of using 2 days, I will use the 1 day for 400 pesos only. So activity F, activity F is 400 pesos, and then I will use their 1 day. So 400 minus 400. I still have 100 pesos to utilize. Okay? But then we cannot use that anymore. Therefore, we now have 5 days. So we now have 5 days to reduce. Okay, so 5 days reduction. From the total project duration. So you can save 5 days for the project. Okay, so that's all for example number 5. Okay, so we have the last example 6. So this is the last example for our study guide number 2. From the given data of PERT CPM network, here you have activity A to F, and then it states here there's no node, but there is a statement here, the preceding activity, and then we have the normal time and the crash time, and the cost per day to crash. So the cost per day is already here. So this is the cost to crash the project, right? So give the critical path and duration of the project. B, assuming activity A started and finished on time, give the number of days that activity B can be delayed without affecting the duration of the project. Then C, if activity C and E are crushed, what is the new duration of the project? And D, assuming the indirect cost is 100,000 per day, which activity should be crushed to reduce the project duration by 1 day? Okay, again, since it's looking for the critical path, we will draw the network, PERT CPM network. Okay. For activity A, the preceding activity is the start of the project. So let's say here, 0 to 1, this is your activity A. For B, it will start, so activity B will start after A is done. So we will have B here. For C, it says there, the preceding activity is the start of the project. So it's from node 0 also. So let's say here, this is 3, activity C. So I did not put 3 here because number 2 is already here. So I decided that it should be, the higher number should either be here or it is after the smaller number. Okay, next D. D will start when C is finished. So here, no. How about E? So E will start when D is finished. So here, so this is 5. Next, it says here, F will start when B and E is finished. So where is B and E? So there. So there you go. So that is F. So that is the drawing. No. Wait. What's this? So it says there B and E. Therefore, there is no node here. Therefore, this is straight. And so this is 1. Then we will change this into 2, 3, 4, and then 5. Okay, so let's arrange that here. C, D, E, F. So let's put the duration first. We have A is normal time 6, B is 10, C is 5, D is 4, E is 9, and then F is 2. So which is longer? 5 plus 4 is 9, plus 9, 18, plus 2 is 20. 6 plus 10 is 16, plus 2 is 18. So C, D, E, F is longer. I will draw here 0 to 2 for C, and then 2 to 3 for D, and then 3 to 4 for E, and then 4 to 5 for F. And then as for B here, for A, so it will be around here. So I don't know, let's put here 1. So this is A, and then for B it will go to 4, right? So this is now our new diagram. So for A, we have here 6, duration 6, B, A, 10. Then F is 2, C is 5, D is 4, E is 9. So, critical path and duration of the project. So, for paths. For paths, we have here A, B, F. First one is A, B, F. Next path is C, D, E, F. So, C, D, E, F. So, ABF is 6 plus 10 plus 2. So, that is 18 days. And then we have C as 5 plus 4 plus 9 plus 2. And that is 20 days. So, this is the duration of the project. And this is the critical path of the project. Okay, so we are able to solve for A. Now for B, assuming activity A started and finished on time, so activity A started and finished on time, give the number of days that activity B can be delayed without affecting the duration of the project. Remember that our critical path is located here. Therefore, the activities that you can delay is A and B. Now, it says there in the problem, assuming that this activity A finish on time. So, how about B? How will you find the number of days that you can delay activity B? So, what is it looking for activity for B? For here. It's looking for the float. It's looking for its float. So, float here is actually C, D, E, F, the parallel activity. They have the same start and same finish for the arrow. Minus A and B. Activity A and B. So, that is equal to 5 plus 4 plus 9 minus 6 plus 10. So our float there is 2 days. That's the answer. 2 days to delay activity B without affecting the duration of the project. Okay, next, letter C. If activities C and E are crushed, what is the new duration of the project? So, letter C. Here, if C and E are crushed, what is the new duration of the project? New duration. So, in case it is crushed, then instead of using C, D, E, F normal, so C, D, E, F normal, you will now use the new one. The C and E is crushed, and then D and E, the former. Okay? So, instead of using 5 days for C and 9 days for E, we will use 4 and 8. So, we have here C, D, E, F. So, we're using the critical path. Okay? So, C now is 4 plus 8 plus 2. So, this is now 18 days. Now, for letter D, okay. Last question. Assuming the indirect cost is 100,000 per day, which activity should be crushed to reduce the project duration by 1 day? So, we need to take note here that activity to be crushed should be along the critical path. Okay? So, which is the most economical to crush here for 1 day? So, it's requiring only 1 day. The most economical, and I'm eyeing it, is 30,000 pesos. So, activity C. C, this one, it's 5 minus 4. You have 1 day to crush, and that costs for only 30,000 pesos. Okay? Look at activity F. If you crush activity F, that would be very expensive, because that means 80,000 a day. Okay? This one is also expensive. For 1 day, you are paying 60,000. So, it should be activity A. Activity C. Okay, so that's for example number 6. So that ends this lecture video for study guide number 2 under the topic PERT CPM Network.